Hello students, welcome to the recitals in depth. Herein, we will cover crucial topics from the Science and Technology section from Recitals magazine of April 2024. The broader themes which we are going to cover are as follows. First, we look into the concepts from space science like solar flares, what are comets, etc. Then we learn about new innovations in space technology and the role of precision timekeeping. Then we look into chemical contaminants and green energy sources under the chemistry theme. And last but not the least, we look into India's innovations in the field of science. So to enrich your understanding on the same, stay tuned. So students, now let's have a look what all are the topics that we are going to cover from the Science and Tech section that are covered in the month of April magazine of recitals. So here are the following list of articles in front of you. So in the first one, we will read about what is White Rabbit technology and what is the collaboration regarding the same. Then we will read about solar flares, coronal mass ejection, very much in news. We are also going to read about their classification, extremely important for exam. Then we are going to read about a moon of Jupiter and the probability of finding ozone in it and also life. Henceforth, this is ozone on Callisto. Then we will learn about the viability of having atomic clock installed in different parts of India so that we can have one nation, one time. Then we will see what is Pratyush. Then we will understand about the Kodaikanal Solar Observatory, 125th year since its inception has happened. Then we will read about a very important comet. This is Mother of Dragons comet. Then we will read about a very important chemical that has been causing contamination in the waters of India. This is the per and polyfluoroalkyl substances. Then we will read about a different kind of fuel cell, as you can see, the magnesium cupric oxide fuel cell. Then we will read about a private satellite launched by India, the TSAT-A1. And finally, we will see what is the viability of having time standards, a different time standard for moon as compared to what we have on Earth. So let's get started. Starting with the first topic, we have the White Rabbit collaboration. Now, if you have watched or if you have read the Alice in Wonderland book written by Lewis Carroll, you must have heard about the character of White Rabbit. A white rabbit who's always in a whimsy and he is always carrying a waistcoat and always carrying a clock with him because he's very punctual and he wants to get things done on time, and at the same time he's always late. So basically he symbolizes time precision and time steadiness. So this character has actually been used in order to have a reference for time steadiness and time precision technology that should be there around the world, and therefore the name is White Rabbit. So this is based on a technology which is known as the White Rabbit technology. So which demarcates two things, which showcases two things. First of all, that there should be time precision. And when I'm talking about precision, we already have got global clocks which are precise and synchronized to the extent of seconds, But we want more precision. We want sub-nanosecond precision. So in order to achieve this kind of precision, we would want something which is known as White Rabbit technology. The second thing is time and data synchronization. Time and data synchronization. Now this will be very helpful in conducting experiments which are going to reveal the secrets of universe, which are going to be covered across different distances, across wide distances. So in order to synchronize the devices. For example, have you heard about the Large Hadron Collider? This is world's largest particle accelerator. Now what it does, it basically sends two beams of particles and it wants these particles to be collided, as you can see. Now the problem with this is the particle motion is very high, even higher than the speed of light, and as a result of this you would require higher precision, higher amount of data and time synchronization on the parts of the two accelerators which are sending them, so that we will be able to get the desired result. So therefore there is utmost need, especially in the era of Industrial Revolution 4.0, where we are indulging into time and data a lot. Data is the new oils, and therefore we can say that synchronization is the need of that, and all of this can be provided with the help of White Rabbit technology. So many countries came into fore, and these countries called for having a White Rabbit collaboration. So this White Rabbit collaboration is in news because CERN, which is European Agency for Nuclear Research, which is situated where? It is situated in Geneva. Launched in the year 1954, having mostly European members, and the only non-European member that it has is Israel. Then what about India? Is India a member of CERN? India is an observer. India has got the observer status of CERN. So it has called for creating a white rabbit collaboration. It will be a multidisciplinary collaboration comprising of your institutes, academia, of companies, of global institutions, for example, CERN, etc. So therefore, people want that all of us should come together in order to achieve these two goals: time precision at sub-nanosecond, and also time and data synchronization. So I hope you've understood the gist. Now the second important point to be noted from this collaboration is that this technology works in something which is known as open source code technology. Open source code means that, let's say you are using Excel or you are using Google Slides. More often than not, in the previous times, you were not exposed to the original source code, but now with the evolvement of this open source code technology, almost all the applications, especially backed by the government, backed by the big companies, they provide you the flexibility to look into this code and also to modify the source code so that the data transparency, the data control becomes more easier. So White Rabbit technology works on open source code. Now this brings me to the next question. Consider the following. Some of the applications launched by Indian government have been given. This is Arogya Setu, CoWIN, DigiLocker and Diksha. All of them launched by Indian government basically. Now you have to tell which of the following are built on the top of open source digital platforms, which means they are using open source code technology. So as I've already told you, in order to decentralize the data, most of the big tech companies, most of the current governments are using all the portals on open source digital platforms only, and therefore the answer would be all of the above. Alright, so here we have solved the prelims question of 2022 as well. Now let's quickly also read about the CERN, which is very important for UPSC. So CERN has been instrumental ever since its inception, that was made in 1954. As I have already told you, it basically works on creating a lot of researches on the standard model of physics, which includes dealing with quarks, hadrons, leptons, basically the subatomic particles. So who are these? And actually understanding them will help us to explore the secrets of the universe. For example, the Higgs boson particle, the God particle, that has been detected by this particular gigantic mission itself. Now if you talk about the location, it is located in Europe, especially in a region called Meran. And specifically located at the border of France and Switzerland. So this you have to remember. There are two basic components of it. First is the Large Hadron Collider. This is world's largest particle accelerator, as I've already told you. And second, it contains of the other particle accelerators. So please remember, it has got both accelerators, and once the particles have been accelerated to a very high velocity, then they are being collided in order to see how the subatomic particles interact with each other. Okay, to conduct all these experiments, please understand they have got further components, which is the ALICE. ALICE will study plasma matter, that too the quark plasma. Okay, then there is ATLAS. ATLAS will make researches on the Higgs boson. You must also know the achievemers of the CERN laboratory. The first one, have you heard about World Wide Web? We all use it in the internet. It was created by Tim Berners-Lee. In this CERN laboratory itself. Next is, in 2012, a breakthrough research was made by the introduction and by the discovery of what we call as Higgs boson, or what we also known as the God particle. So this was also detected, and this was also basically introduced for the first time via the CERN experiments only. So for which we have understood that it has got ALICE, it has got ATLAS. So question might be asked that ALICE and ATLAS are parts of which experiments? So it is a part of CERN. Okay. Now, whenever we talk about any emerging technology, for example, this white rabbit technology, the most important aspect when we want to prepare for UPSC dimension is to prepare its applications. So let's discover what are the applications of this white rabbit technology and collaboration vis-a-vis. So the first one is to detect a lot of things which have been rendered undiscovered, which are fueling our curiosity. The first one is, of course, how the subatomic particles interact with each other, right? The second one is to detect neutrinos. Then we have to also detect radio waves. Why do we want to detect radio waves? Because radio waves come from radio waves or X-waves, X-rays. They actually come from very, very far off the universe. So we'll be able to understand the theories and mysteries of black holes, of active galactic nuclei, and other spatial objects with the help of all these three. The problem with them is that they are very fragile and critical. So in order to detect them, what we require? Immense amount of time synchronization, data synchronization and precision. So let's have a look into the application. The first application is in the high energy physics. So the high energy physics program is actually conducted by CERN itself, by Large Hadron Collider of CERN. So the Large Hadron Collider would require all the detectors. There are so many detectors, they all need to be synchronized with respect to time and data. Only then they will be able to create results which are very high on accuracy. So all the point over here is to establish very high levels of accuracy. The next is neutrino telescopes. Now there's not just one telescope which is there to detect the neutrino. There is an array. There are multitudes, multiple neutrinos all over, and therefore there is an array of telescope as well. Now because there are arrays, which means there are a lot of telescopes situated, it means we also need to synchronize all these telescopes which are probably at a very high distances. They are at continental level distances. So again, synchronization is the need of the hour in order to understand the exact time of the commencement of neutrino or exact alignment of the direction of neutrino particle. So for that again we need synchronization. So therefore neutrino telescope is again the need of the hour. Second is in radio astronomy, just like the neutrino telescopes, don't we already have radio telescopes? You must have already heard about the square array kilometer. So square array kilometer observatory is world's largest telescope that has been created by making a lot of telescopes in a serial connection with each other, and they are placed across the continent. Of course would require synchronization. So in order to understand radio astronomy, you would require white rabbit technology. But not just for discovering physics, it is also important for finances. So the high frequency trading that happens, especially in intraday, the volume has also increased a lot. So you see that even in 1 second the value changes, causing huge amount of losses, huge amount of gains. In order to understand and synchronize all these portals, all these digital markets together, financial markets together, you would require such technology to be introduced in financial markets as well. Then last but not the least, it will help us in putting some leverage to the future applications. For example, putting leverage to quantum technology. Quantum technology is very sensitive, and therefore the synchronization of qubits, again asked in UPSC, this is the basic unit of quantum technology, like how we have got bits in the computer technology. So synchronization of qubits is extremely important, and the synchronization can be achieved with the help of white rabbit technology. So in this session we have read what is white rabbit, why have we used white rabbit as a symbolization, why is this technology called so, what is the news about it, what is CERN, what is Large Hadron Collider, what are the applications. So we have concluded all of it under the white rabbit collaboration. The year of 2024 was full of news about the solar flare event. In fact, the month of March, the month of April, in fact the month of May as well, it saw a lot of solar flares, so much intense that they not only made an impact on the typical polar hemispheres, but they also made an impact on Ladakh. They were also seen from many parts of the other continents. and therefore we are going to read about what is solar flares and what has led to the intensification of the solar flares, so much so that now the phenomena can be observed from India as well. So we are going to read about the X-class solar flare. Basically, we are going to read about the classification of solar flares. Now, before getting into what is solar flare, what is the associated terminology, for example, coronal mass ejection, we must understand the solar or the sun anatomy. To understand that, first of all, what is sun? Sun is nothing but a hot ball, a gigantic hot ball of ionized gases. The gases are ionized because the matter could not prevail in the solid, liquid or gaseous form when it is subjected to extremely high temperature, let's say of 5000 kelvins. And this happens in the case of sun. The energy is fueled by something which is known as nuclear fusion process, which emanates huge amount of energy. Therefore, it occurs to it that a lot of fusion reaction happens, and fusion causes emanation of lot of energy, and as a result of this we get a hot ball of plasma, which is the fourth state of matter. Now, in the matter of plasma, the gases are existing in ionized form, which means we are having a lot of charged particles. Now, what happens when such huge amount of charged particles are rotating in a very high motion? Why? Because the sun has got rotation. So the moment sun starts rotating, therefore the plasma or this electric charges will also start rotating, leading to creation of electric field. Now, as you know that with every electric field, there is a proportionate and perpendicular magnetic field. So our sun is characterized by one more very important thing, which is having very high magnetic fields. Now, the nature of magnetic field is such that they keep reversing themselves in every 11 years. In every 11 years, they will shift from their north to south alignment towards, let's say, the east-west alignment. Or again south to north alignment. So therefore, the changes in alignment of this magnetic field will lead to something which we know as the sunspots or the dark spots. So if you observe sun from the telescope, you will see that at some time, especially when the solar activity on the sun is very, very high, you will see a lot of dark spots in it. These dark spots, or known as sunspots, they are the resultant of the magnetic field lines itself. So what happens in some parts of the sun, these magnetic fields starts coiling. And when they start coiling, they put so much pressure on the surface of the sun in these two extents that they lessen up the temperature, because the reaction energy couldn't escape out, because it is being subdued by the immense pressure of the electric fields. As a result of this, you will see dark spots, because in these areas the temperatures, though it's very high, but it's still less as compared to the other parts of the sun. Now, more the dark spots, which means more amount of magnetic field lines, which means more amount of solar activity, and such event is known as a solar maximum. So now let me introduce another topic to you. What is solar minimum and what is solar maximum? So for that, please understand that a solar cycle is of 11 years. The sun moves from a solar cycle of 11 years, which means at one point in time it receives solar minimum, which means having minimum amount of solar activity corresponding to minimum amount of dark spots. As you can see, this is a situation of solar minimum. And then it moves towards solar maximum. And then again it goes to solar minimum. So the time taken from one solar minimum to another solar minimum is known as one solar cycle, which spans of about 11 years. And in between it, let's say in about 5 to 6 years, it reaches something which showcases the largest amount of solar activity in the form of solar maximum. Right now is the time, in fact, the end of 2024 and the beginning of 2025 is the year when the earth will be seeing the highest amount of solar activity from the sun, because we are reaching the solar maximum year. Okay, so because of this, there is heavy intensification of the solar flares that are coming. Now, what leads to the creation of these solar flares and the related concept, which is coronal mass ejection? To understand that, please have a look into this image. So we have already told that, let's say, a solar maximum year is going on, lot of solar activity on the surface of corona. As a result of this, lot of magnetic fields are there. And this magnetic field is capable of carrying the electric charges or carrying the amount of radiations, heat radiations that are being created by the energy of the sun. Now, because the radiations are going very, very far away because of being in the era of solar maximum, they will also carry radiations in them. Please understand, when these radiations become more strong, they take a form of wind, they take a form of storms, which are known as solar flares or solar storms, because they hit the other object with a very high speed or very turbulent speed. So these are known as solar storms or the solar flares. At the same time, it might happen that the state of matter over here, what is the mass? What is the mass of sun? The mass of sun is the fourth state of matter, plasma. So when this plasma also starts ejecting out via these radiation field lines, then it causes ejection of not just the radiation, but the ejection of plasma or a kind of mass. They are more deadly, they are more significant during the years of solar maximum, and therefore they are known as coronal mass ejection, where not just radiations but plasma also moves out of the surface of the corona or the surface of the sun and hits other bodies, other celestial bodies which are in the influence of the sun, especially Earth. So depending upon the phase of the solar cycle, the intensity of these solar flares also vary. So the moment we reach the solar maximum, the intensity also rises. This intensity can be broadly divided into 5 classes. First is the A type, then the B type, the C type, the M or the median type, and the highest intensity solar flare, which is the X type. Now please remember, when we are moving from A to X, we are moving from low intensity solar flare to high intensity solar flares. So the solar flares in the A, B and C classification are not that intense, and as a result, yes, they cause some impacts to the Earth, for example, creation of auroras, etc. But they do not cause any destructive impact on the Earth. And they keep coming into the Earth and they go unobserved. But when we enter the M classification of solar flare, this is when we see little amount of blackouts happening, especially influencing the northern hemisphere and the southern hemisphere. So they causes blackout, but the M1 causes blackout in the polar region specifically. Then comes the highest intensity solar flares, which we are seeing right now. So the X-class solar flares are those which have the potential or the energy to cause blackouts in most parts of the world. So because it is having such a high intensity, therefore it's a concern for us that we are being struck by the X-class solar flare. The last or the heaviest intensity solar flare that we observed was the X23, observed in the year 2003, and this led to what we know as the Halloween storm. This question was also asked by UPSC in the optional examination. But anyway, we are talking about the X-class solar flare, and these are some of the instances. Now, why are solar flares a cause of concern for us? Because of the impacts it has. Of course, it has got some positive or unharming impact, for example, creation of auroras or creation of some lightning in the sky, especially in the northern and the southern hemisphere. But that is non-destructive, but it also causes certain destructive impact. For example, it can overwhelm the electronic systems. It can overwhelm the transmission lines, leading to causation of blackouts. They can also cause fires in many telegraph stations or communication centers, because again, it overwhelms the entire power grid system with a lot of charges. Okay, so these are some of the destructive impacts have already been observed. So first of all, it was observed in the Carrington event, which is named after the British astronomer who first observed it. And the Carrington event was actually somewhere in the Caribbean region, and this caused massive fires in the telegraph stations, along with showcasing some stunning auroras in the Caribbean region. This is not in the polar region, so please remember this. Next is the Great Magnetic Storm, which came in 1989. This also led to a lot of power disruption in the satellite, disruption in avian communication, etc. Then the Bastille event or the Halloween storm of 2003. Kind of making clear to you that all these years will amount to solar minimum or solar maximum. They will translate to years which are having solar maximum, highest amount of solar activity, and therefore what we see heavy intensity of solar flares, we see heavy intensity of coronal mass ejection. Okay, so I hope this concept is clear to you. Now, do you know that a team of scientists have recently proposed the prospects of having life on one among the moon of Jupiter? This is the Callisto, and which makes us question, what gives the chances of a planet to sustain life, to thrive life on it? Of course, it is availability of soil, availability of water, right amount of air, but most importantly, the first is to have a conducive atmosphere which can safeguard the territorial organisms, which can safeguard the territorial lives, and at the same time, which safeguards us from the harmful ultraviolet rays of the sun. So that's the first thing. We want an atmosphere which is conducive. The second thing is we want oxygen which is quintessential for thriving life on any planet or any place. And prevalence of both can be justified by the discovery of a particle or an element which is ozone. So ozone, when it gets influenced by the ultraviolet radiation of the sun, it gets disintegrated into what? It gets disintegrated into oxygen molecule as well as an oxygen radical. And therefore, it not only creates a conducive environment for the life to thrive, because it protects us from the adverse radiations of the sun, but at the same time, it releases something which is extremely important for thriving life. That is the oxygen. So therefore, when they declared that there is prevalence of ozone on Callisto, then therefore it also reveals to us that it might be having prospects of sustaining life. Now, let's talk about Callisto quickly. Callisto is one among the larger moons of Jupiter. So please remember, Jupiter, which is the largest planet of the solar system, is a Jovian planet. Jovian planet, which means it is a huge ball of gas. It is a huge gas giant, along with the other three. Now, along with this, Jupiter also hosts more than 95 moons on it. But this is not the largest number of moons that is hosted by any planet. So when it comes to which planet hosts the largest number of moons, do you know the answer? It was considered before as Jupiter, but now it is Saturn. So Saturn wins over here by having 149 approximate moons on it. But the largest moon of the solar system is still hosted by Jupiter. What is the name? The name is Ganymede. The second largest is Titan. Titan is hosted by Saturn. The third largest is Callisto. Callisto, which is the point of our discussion over here. Right? This discovery was made by the Hubble telescope and a lot of experiments that different astronomers were making via their space agencies. Now let's also quickly talk about the other moons of Jupiter. So we have got Europa, Ganymede and Io. These three, along with Callisto, not Callisto, but these three actually have been discovered by Galileo. They have been discovered by Galileo. Callisto has been discovered very recently in 18th century. And we also have Calichor and Amalthea as its moon. So you have to remember moons of each and every important planet. Now let's have a look into how Callisto looks. So this is the image taken up by Hubble telescope, and the findings are that it has got prevalence of sulfur dioxide ice. So large amount of sulfur dioxide, when it gets influenced by the UV radiation, it again produces free radical oxygen. Which when combined with other free radical oxygen can create oxygen, and this again when it combines with other free radical oxygen can create ozone. So it has got prevalence of ozone in it, which can tell us that it can also have potential of thriving life on it. Okay. The second finding is that it had got huge concentration of ammonia. So ammonia gas is a very potent greenhouse gas, which means it has got the capability to keep this moon warm. Okay, so therefore ammonia also showcases that it can host a conducive environment for the life to thrive. Second is, as you can see, it is heavily cratered. Lot of craters can be seen. Why is it heavily cratered? Because it has been struck and impacted by a lot of meteors and asteroids of late. Okay, then it also showcases low seismic activity. Even though a lot of craters have fell into it, it doesn't show a lot of seismic activity from within. So these are some of the features of Callisto. Now you should also know that why is it heavily cratered? It is because of heavy impact of asteroids. Why is it impacted by asteroids so much? Because it is a moon of Jupiter, and in between the orbit of Mars and Jupiter lies what you call as the asteroid belt. So therefore it is heavily cratered. So everything kind of makes sense once you become logical for it. Okay. Now, do you know that India has joined League of 4 nations which have been exclusively using the rubidium clocks for synchronizing their GPS satellites? So, what are these 4 countries first of all? These 4 countries are US, UK, we have Japan, and we have South Korea, and along with this, now our India has become the 5th. So only 5 countries in the world are currently deploying or about to deploy rubidium clocks for higher or greater precision timekeeping in their indigenous satellites. When I'm talking about indigenous satellites, sure, all these countries have got indigenous satellites, but do all of them have also got their indigenous regional navigation system equivalent to GPS? UK has, US has, Japan has, but South Korea does not have. And what about India? India has got IRNSS, which we are going to read in next slide, also named as NAVIC. In this NAVIC navigation system, they have already deployed the rubidium clocks for utmost accuracy, but at the same time, now India is set to deploy rubidium clocks in all the satellites, in all the, especially these geostationary, all these locational satellites. Let's talk about the significance and the concept of GPS first. GPS was introduced by USA, especially by US Ministry. Previously it was named as Navstar. Then it later became GPS. Everybody, all the countries are currently using GPS, Global Positioning System, in order to locate their spaces, right? But then India was denied the access of GPS during the Kargil war, and because of which it was not able to get the information, the locational information of Pakistani intruders. This happened back in 1999, and since then, India considered that we have to have atomic clocks created indigenously for us and deployed for us. The importance of these atomic clocks is their high degree of efficiency and accuracy. So when they tell the time, they don't tell normal time. They tell time to the degree of nanoseconds. They tell you very, very precise time. And therefore, they are extremely important for locating somebody, and therefore extremely important for being deployed in systems like regional GPS. And so therefore, India currently hosts 2 atomic clock laboratories. One is located in Faridabad, Uttar Pradesh, and the second is located in Ahmedabad. Both of them are currently synchronized and managed by the National Physics Laboratory, which is headquartered in Bengaluru. So it hosts these already 2 set up atomic clock observatories. Now, when I'm talking about atomic clock, what exactly do they comprise of, and why is this important? Do you know how you calculate 1 second? The 1 second, that is the basic, that is the SI unit of time. 1 second is actually calculated via the amount of vibrations of a cesium clock. Cesium atom and rubidium atom, these 2 atoms are considered. Their vibrations are calculated and measured, and because of the stability of the vibration, it is said that when the cesium atom will vibrate to the extent of 9.1 into 10 raised to the power 9 times, this will become equivalent to 1 second. The reason for this is very accurate, very stable, and the loss of second will only happen after millions of years. So therefore, this is the most reliable metric of time gauging. As you can see that it is able to, the cesium and the rubidium are able to calculate and track time at very micro levels. Therefore, they're essentially used for GPS tracking. And so therefore, we use cesium clocks a lot of times, but this time we are using rubidium clocks. The reason for this is, first of all, they are more precise, and most importantly, they are more compact and concise so that they can be fitted into the laboratories or into the satellites, or in fact in the micro satellites as well. So therefore, we use rubidium. The atomic number of rubidium is 37. And where is cesium located? Cesium is located just below it, with an atomic number of 55, which is more heavier metal. All of them, both of them are metals, S block metals, S block elements. Which one is more heavier? Cesium is more heavier. So which one will be more concise and compact? Of course, rubidium, and therefore rubidium will be deployed in the satellites. So I hope this is clear to you. Now taking you back to a discussion where we have to read about the regional navigation satellite systems, because it's extremely important topic for UPSC. So I already told you that among the previously discussed countries, only US, UK and Japan along with India has got their regional navigation systems equivalent to GPS. The other country is China. So currently in the world, only 6 countries have got their own regional navigation system. Okay, how many countries are there? Only 6 countries. Let's try to name each of them. So the navigation system of US is known as GPS, previously known as Navstar. The GPS system used by UK is same as that used by the entire European Union, and this is named as Galileo. This is named as Galileo. The one used by China is known as Baidu. The one used by India is known as Navik or IRNSS. And the one used by Japan is Quasi-Zenith satellite system. So we have got overall 6 countries. Now let's dive into greater details about India's regional navigation system, that is the NAVIC system. The full form or the other name is Indian Regional Navigation Satellite System. It comprises of 7 satellites that are deployed in the geostationary orbits. But there are 2 orbits, one is geostationary and second is geosynchronous. About 3 satellites are observed or are deployed in the geostationary. You must be knowing that in order to have an overall evaluation or mapping of the Earth, minimum of 3 satellites, 3 geostationary satellites are required. So we have put 3 satellites in the geostationary plane and 4 in the geosynchronous. So this is how you can see, this is a geostationary and this is a geosynchronous. So this is the arrangement of these 7 satellites which is going to give us a regional GPS for India. And this is not just for India, but it will also cover up to 1500 kilometers beyond its border, which means they are not giving us area. They are giving us kilometers, the distance beyond our border. So it's not just catering to India, but also beyond the border. Okay. It will be using what? Rubidium atomic clocks. 3 rubidium atomic clocks will be used for high degree of precision. Okay. Now, some part, there are 2 segments of it. Some part of it will be open to all the users, and the other parts of the frequency will only be used by military purposes or for security purposes and vigilant purposes. Okay, so this is about IRNSS. Now, can we try to solve a question which was asked by UPSC in 2019 about it? Let's have a look. So first of all, question is, which of the following countries has its own satellite navigation system asked by UPSC in the last year itself? Which of the following have their own satellite navigation system? So we have read Australia doesn't have, Canada doesn't have, not Israel, it is Japan, having Quasi-Zenith satellite system. Okay, next question asked in 2018 with reference to IRNSS, consider the following. IRNSS has 3 satellites in geostationary and 4 in geosynchronous. Is this correct or not? It's absolutely correct. Okay, next, it covers entire India and about 5,500 square kilometers beyond its border. I've already told you, first of all, it's 1500 and the unit is kilometers, not square kilometer. right? It's not an aerial distance. So therefore, second statement is incorrect. Then the third one, India will have its own satellite navigation system with full global coverage by the middle of 2019. We are here in the year of 2024. Do you see any such development happening? Have you even heard the news of it? No. So therefore, this is incorrect. The correct answer is only 1. Now, do you know that astronomers are planning to put a telescope made by India, that is the Pratyush telescope, on the far side of the moon for better observation of the cosmic dawn? What is cosmic dawn? And what are the other telescopes which have been deployed to observe the universe and specifically located on the moon? So let's have a look. First of all, what is a telescope? Now, a telescope could comprise of various lenses. It could have a combination of convex lens and concave lens, or both lenses could be convex. But the idea of a telescope is basically to gather the light and converge it at one place so that we can be able to see the space or the objects which are located at a very far off distance from us. So therefore, in order to speculate, in order to understand, let's say, the moon of the Jupiter, the moons of the Saturn, in fact the Jovian planets, the far off galaxies, Galileo Galilei introduced telescopes. So telescopes are important for understanding the distant objects. Which lenses telescopes use? They use convex lenses for converging. Convex lenses are used for converging the light, right? Now, when we talk about it being located in the far side of the moon, as you can see that it will be deployed in the far side of the moon. The far side has been a part of curiosity for a lot of astronomers of late, because this is the part of the moon which never sees the light of the sun. And therefore, to understand about its mineral composition, seismic activity, radiation influenced by it, we're about to install a telescope over here, which is not just going to have observations of the far side of the moon, but also of the universe away from it. And when we are talking about the aim of the Pratyush telescope and installation in the far side, we are trying to put into observation the revelations of cosmic dawn, which means this telescope, which will be able to operate in a frequency of 30 megahertz to about 250 megahertz, will be able to catch the light from one of the earliest stars and galaxies, which eventually were born when the universe dawn happened, or the cosmic dawn happened. This is the aim. The aim is to study about the stars and the galaxies belonging to the cosmic dawn. Okay, this is the Pratyush telescope. Pratyush telescope was created by two organizations. One is the Raman Research Institute, and the second one is our ISRO, Space Agency, Premier Space Agency of India. They both created Pratyush telescope. These are the qualifications, the characteristics of Pratyush telescope. It will be able to gather the light in the radio wave frequency in this extent, up to this range. Then they thought of creating a two-phased mission. According to the first phase of Pratyush mission, it will be deployed in the Earth orbit only. First of all, it will be deployed in Earth orbit, and then it's in the second phase. Once we observed and we're assured that it's performing well in the Earth orbit, we will try to maneuver it to the moon orbit, that too in the far side. To the moon orbit, that too in the far side. So basically, this Pratyush is a 2-year mission. Observatory mission. Please remember, Pratyush is not a supercomputer, if they may ask in the prelims. It's a radio telescope, a very powerful radio telescope created by India, specifically by the Raman Research Institute. By the way, Raman Research Institute is located in Bangalore, and by ISRO. Alright, now, is Pratyush telescope the only telescope to be deployed on the far side of the moon? Answer would be obvious no. So there are more missions which have not been taken up yet, but they are still in the ideation process, and they are going to get implement on 2025, 2026 and 2030 respectively. So these missions, first of all, is the Lucy Night project, the Lunar Surface Electromagnetic Experiment project. This is carried by two organizations, NASA and the Berkeley Lab. Okay, so this will bring a laboratory on the far side of the moon. It is to be launched in 2025. The second one is China's Moon Orbiting Radio Telescope. They have already deployed a satellite, which is Kikao satellite, and they are about to bring this telescope in the year 2026. Then European Space Agency's Argonaut. So you might be asked, what is Argonaut? What is Lucy Night project all about? Because UPSC has already asked question on ELISA. And it has asked question for it about 2 times. So therefore, please be mindful that these are the telescopes to be deployed on the far side of the moon for having gravitational observations, cosmic observations, observations of the cosmic dawn, etc. Now, what are the other major laboratories or observatories that are brought by India? So first of all, please remember we have AstroSat. AstroSat has been launched, and this is a multi-spectral observatory. It has got the capacity of observing across multiple wavelength, the X-ray and the UV rays and the infrared rays and the visible light spectrum. This is AstroSat. The second one is, obviously, we have got Pratyush. Then we have got the Saras project. This is also a telescope launched by India. Then we have another observatory, which is 30-meter telescope. So 30-meter telescope is there in Pune. Maharashtra. So these observatories you should remember. So as we have talked about the observatories in the previous topic, now we will dwell into the Kodaikanal Solar Observatory. And why was this in news? The reason for this is it is about to commemorate its 125th birth anniversary, which means that the commencement, the inception of the solar observatory must have happened in the late 19th century. In fact, it was created in 1899. What led to the creation of solar observatory during British time? The reason was the Great Famine that occurred across the different countries of the world. The Great Famine, which occurred from 1875 to 1707, left most of the countries puzzled as to what is the reason of this widespread global famine. They had sure clues about the monsoon and the parameters that are affecting the monsoon, but they wanted to explore the impact of solar cycle, the impact of solar radiation on the monsoonal cycle and on the climatic cycle of the earth. So for that, not just India, but the other countries also started setting up solar observatories. This is one among the first physics laboratory created in India, that too in the Kodaikanal district of Tamil Nadu. Before dwelling into it, let me first make you understand where is Kodaikanal located and why this place was chosen. The first reason is because it is located in hills. It is located in Palani Hills. So because it is located in a hilly area which is very much near to equator, therefore it becomes very easy to observe the sun in rather clear atmosphere, which was very conducively found in Kodaikanal. Now, taking you to a little geographical angle of it, when we talk about Palani Hills are a part of Eastern Ghat. They are not a part of Western Ghat. Let's try to locate it in the map. So you must have already known that when it comes to the southernmost hills, these are the Cardamom Hills. Cardamom Hills are a part of essentially Western Ghats. When you talk about the hills of Tamil Nadu, the hills of Tamil Nadu start with Javadi Hills, then we have got Shevaroy Hills, then we have got Panchai Malai Hills. After which we have Palani Hills, and to the south of or the southernmost hill range of Eastern Ghat is Varushnad Hill. So what is the sequence? Javadi Hill, Shevaroy Hill, Panchai Malai Hill, then Palani Hills, then Varushnad Hills. So please remember this chronology. All of them belong to the very dissected Eastern Ghats. And therefore, because it was located very, very close to the equator and having very conducive situations, having hilly terrain, so therefore it was chosen as solar observatory. Now, it was suggested by the Famine Commission that was appointed by India in 1899. That's when they recommended that there should be establishment of a solar observatory. Now, what is the significance of the solar observatory so far? This observatory has been instrumental in detecting helium atom, the presence of helium atom. The second thing is it also led to the discovery of Evershed effect. So when it was observing the solar regions or the solar spaces, it saw that there are a lot of dark spots or sunspots, and these sunspots are moving in a very radial fashion, and the solar flares are also curving around them. This is known as the Evershed effect. This was discovered for the first time by Kodaikanal Solar Observatory, and still it is very unfortunate that many of us don't know about this. Okay, next is it also led to ionosphere measurements in many ways, and it also led to discoveries which helped us to bring some synchronous conclusions as to how the solar cycles can impact the climate of the earth, especially of India. Now let's have a look into some other observatories. So these observatories again are located in terrain. As I have told you, Kodaikanal is located in terrain, right? So they are also located in terrain, but they are not necessarily solar observatories, but they are very important for exams, so we'll be having a look. First of all is Indian Astronomical Observatory. So a place which offers huge leverage to the astro-tourism. Why? Because it has got natural ambience of dark sky. Dark sky makes the reduced amount of light pollution and good visibility. The darkness in the sky ensures that we are able to observe a lot of astronomical observations like constellations, stars, planets, galaxies, etc. So therefore a large-scale observatory has been created in Hanle. Please remember two laboratories. One is Hanle and the Mirak laboratories or the observatories. They are situated where? If you draw the map of Jammu and Kashmir, they are located over here in the region of Ladakh. Okay, this is Astronomical Observatory. The next observatory is the Mount Abu Infrared Observatory. Infrared Observatory, of course, it means that it's going to explore the radiations coming from the space, okay, or the spatial objects, for example, other planets. So for this, Mount Abu, which is specifically located in Guru Shikhar, the highest point of Aravalli Hills. So this observatory is created. Next is the Giant Meter Wave Radio Telescope. This is there in Pune, Maharashtra. Okay. Now, we have already talked about the observatories which are deployed on the land, on the surface of the land. But there are, of course, certain other solar laboratories or observatories which are deployed on the space. So let's explore them now. So when it comes to India, we have got India's first mission, which is deployed out of the Earth orbit in order to observe the sun. The solar observatory is deployed about 1.5 million kilometers away from Earth. And this is Aditya L1 mission. The second one is NASA's Parker Solar Probe. Then Helios 2. This is created by NASA and Germany. Basically an organization of West Germany. They both have came together for Helios, and what we know as Solar and Heliospheric Observatory SOHO or Solar Orbiter. This is by NASA and this is by European Space Agency. Okay, so this is space-based solar observatory. Now we are going to dwell for the sake of exam a bit more into Aditya L1 mission. So let's quickly learn about India's first space-based observatory, which is Aditya L1 solar mission, launched recently in the month of September 2023. Now when it was launched, it was deployed not on the orbit of the Earth, as I've already told you, this is space-based. So it was deployed in a very unique point in which a deployed observatory or satellite is able to self-balance itself. Why? Because the gravitational pull by the two celestial systems counterbalance themselves at about 5 points. The first point is one situated between them. The second point, this is Earth and this is Sun, and we are going to talk about Lagrange points created between them. These are the points of equilibrium. So the first point is between them, second is away from them, away from each of them, and then at the equatorial point. The most stability is reached at the equatorial points, but of course we would like to observe the sun. So therefore we want to have more proximity with the sun. So therefore our observatory Aditya L1 is situated somewhere here, which is about 1.5 million kilometers away from the surface of the earth. Okay. Now, which is about 4 times farther than the moon, and then we have already talked about the destination. It will be hosted in the Lagrange point, and then the route is not very important. The spacecraft is important. Now this is going to be an observatory. So observatories are generally launched via PSLV satellite, and PSLV is the most reliable rocket of the ISRO. Therefore it is also known as the workhorse of ISRO. But what is known as the heavy lifter of ISRO? You tell me in the comments, what is the heavy lifter of ISRO, which is able to carry the most amount of weight when it comes to satellite and space missions? Okay, that's a question for you. Anyway, this is about the Aditya L1 mission. So in this topic, we have read about the solar observatories of India, which are deployed in the terrain of the earth. Second, deployed outside the terrain, that is what are the space-based observatories, not just of India, but also of the other parts of the other space agencies of the world. Okay. One fascinating news was a very rare sighting of a unique comet in the northern hemisphere of the earth. This is known as the Mother of Dragons comet. This name was given by European Space Agency. So we don't have any stakes in that, but anyway, this is Mother of Dragons comet. In the scientific term, this is known as the comet 12P or Pons-Brooks. This is not very important, but yes, what is the significance of this comet? We'll understand this. Before that, let me give you a brief introduction about the comet. So comet are those celestial bodies which have highly elliptical orbits around the sun. When I'm saying this, let's say this is the sun. Okay, typically the planets have got equatorial trajectory. They have got elliptical but rather equatorial trajectory. But when it comes to comets, they have highly elliptical trajectory, which means it becomes very, very rare to sight them. So they are the ones who don't very often cross the earth. So whenever a comet comes, it becomes one of the biggest news of that year, because these are very, very rare sighting. Rare sighting, why? Because they have very high elliptical orbits around the sun. What is the reason for this high ellipticity? We'll learn that. But first of all, just understand that these are the icy planets, also known as sometimes the dirty planets. These are the icy bodies. They primarily compose of ice. Ice is the main element. They have dust and they have rocks in them. And because they have got lot amount of rocks in them, so whenever they come close near to any planet, let's say Earth, these rocks shed away and they cause meteor shower on the surface of the earth. Okay, so therefore these meteor showers can also be observed with the commencement of any comet, and comet probably most likely comprises of ice, dust and rocks. Ice is the most important element. Now let's talk about how does a typical comet looks like. So there are different variations, but if you see any comet, it can be truly justified by this image. This image in which you will see a huge ball, a huge shiny ball. This ball is known as nucleus, which is containing the core of this comet. Around this is a kind of vapor which is trying to hide this nucleus. This vapor is the vapor of ice and the dust. So whenever a comet approaches the sun, let's say here is the sun. Whenever it approaches the sun with a very high speed, what happens is the ice starts melting and it starts evaporating at a very high speed. And as a result, the ice along with the dust particles form this tail. You can see two broad tails over here. One is this very fine tail and second is this gigantic tail. So every comet is definitely accompanied first of all by a nucleus and accompanied by a layer of vapor around it, which is known as coma, and therefore this is known as a comet. And second is trail of two tails. The first tail is known as the dust tail because it comprises of prominent gases, prominent dust and the ice particles which are getting evaporated away from the direction of sun. And the second is the ion trail. Here the ionized particles of the plasma The plasma, because of the solar flares of the sun, it evacuates the plasma in this direction, and as a result, you can see an iron tail and a dust tail. Okay, this is a broad composition of a typical comet. Now, to understand this particular comet, have a look into this picture. This is how exactly it was sighted. It was sighted in the month of April. So as you can see, it has got a very prominent greenish hue, greenish color. This greenish color is because of a distinctive element. This is the diatomic carbon. Prevalence of diatomic carbon in the mother of Dragon's comet, and because it looks like as if a dragon is coming with a greenish hue, therefore this is named as mother of dragons. Was it discovered in the year 2024? No, it was discovered in 19th century only, and it was named by European Space Agency, and it is distinguished by the prevalence of diatomic carbon. It is not the nitrogen gas or the ammonia gas which is causing this green color, but the carbon, the diatomic carbon atom. Okay, now let's learn about how do we classify the comets. So comets can be classified into two categories. One is the long period comet, also known as the non-periodic comet. The second one is the short period comet. So it can be classified into, first of all, long period comet, and second is the short period comet. Because those comets which are able to reappear on Earth in about less than 200 years, they are classified as short period, and because you will be able to see at least twice it in one lifetime, therefore the periodicity can also be observed. That is, it occurs again in periodic interval. So therefore they are also known as periodic comets. Can you name example of it? The largest comet that has been seen, observed by us, the Halley comet. Halley comet is a short period comet. Okay, so such classifications can also be broadly classified as the Halley group of comet. When you talk about the mother of dragons comet, it is again a short period comet or a Halley-like comet. Now let's talk about the long period. What if the orbit is too elliptical that it doesn't repeat its orbit, or it reaches near to Earth or near to Sun only in more than 200 years? So if the periodicity is more than 200 years, it is completely unlikely to see the same comet again in one lifetime, and therefore they are known as the non-periodic comet. They are known as non-periodic comet. Can you give me an example of it? Yes. In 2023, in the month of September, a very important comet came. This was the Nishimura comet. Comet Nishimura was sighted, and comet Nishimura appears only after 200 years. So therefore this is classified as a long period comet, right? And there is also one more comet which is Hyakutake. A Japanese name is given. This is also a long period comet. Now what is the reason of this long periodicity and short periodicity? The reason is the source of the comet. Where are these comets actually lying? So as you already know, where are our asteroids lying? Asteroids are mainly concentrated in a belt which is known as asteroid belt, located between the planets Mars and Jupiter. That is where you will see. So in between Mars and Jupiter, you will see the asteroid belts. Most of the asteroids are coming from here. Okay. The next one is you have Kuiper belt. Now Kuiper belt is a giant bubble consisting of icy massive bodies, which is located just outside the Neptune. And if you talk about its distance from the Sun, the distance is of about nearly 500 astronomical units. Nearly 50 astronomical units. Okay, then there is another cloud which is situated away from the boundary of our universe, or just at the boundary of the universe. This is known as Oort cloud. As you can see, it is located very, very far away from the Sun. The distance normally therefore is about 500 astronomical unit to 10,000 astronomical unit. This is the Oort cloud, and it has got huge composition again of what? Icy rocks. These icy rocks, which are originating either from the Kuiper belt or either from the Oort cloud, when they get influenced by the gravity of the sun, they get pulled into the form of comets. The first important thing is they are not asteroids. They're essentially icy because they're very, very far away from the sun, so the sun radiation doesn't reach them. They become icy. The second thing is, if it is coming from Oort cloud, which means it has to take a huge distance, the ellipticity will be huge. Therefore, the Oort clouds will give me the long period comet or the non-periodic comets. Whereas if it is originating from the Kuiper belt, which is pretty much closer to sun as compared to Oort cloud, then in that case, what I will get is a short period comet, for example, the Halley comet. So now I hope you've understood what are the comets. What is the distinguishing feature of mother of dragons comet? You've understood what is the asteroid belt, Kuiper belt, you've understood Oort cloud, you've understood the classification of comets. One more thing is there. What is the difference between asteroids, meteoroids, meteors and comets? We've already understood about the comets. Now we'll explore the other celestial bodies as well. So have a look into this image. Okay. So comet is what? Comet is an icy body that releases gas. It has got a trail of gas. So one is the trail of gas and second is the trail of iron tail. Okay, and next one is a gas tail or the dust tail. Okay, and it has got coma. So these are the components of a comet. Comet have highly elliptical orbits around the sun. The next one is asteroid. Asteroids are rocky bodies which are of course smaller than the planet, but they are big enough to cause huge destruction, mainly located in the asteroid belt. I've already told you the location of asteroid belt. Now when these asteroids revolve around the sun, there is highly likely, in all the likelihood, under the gravitational pull of, let's say, Earth, or under the gravitational pull or the friction caused by the other atmospheric factors, or let's say some other planet's gravitational pull, it might happen that it can get broken up into smaller pieces. Asteroid broken into smaller fragment is known as nothing but meteoroid. So these are the rocky or metallic fragments of an asteroid or a comet or a planet, but mostly of an asteroid. Now what happens? It becomes more easy for the gravitational pull of the Earth to pull such small meteoroids. So it kinds of pull a lot of meteoroids towards itself. But the savior of the Earth is its atmospheric blanket. Okay, now the moment a meteoroid tries to enter into the atmosphere, it faces huge amount of friction. As a result, most part of it is burnt. In fact, most of the meteoroids, even if they come inside, even if they come contact to the atmosphere of the Earth, they get burnt in the atmosphere only. So they do not get the chance to enter the surface of the Earth. And by the way, if it at all enters the surface of the Earth, then it will cause huge impact, huge destruction to the Earth. As already seen, a meteoroid impact caused the end of the dinosaur age, right? So when you talk about the meteoroid, these are the ones which have entered into or which have hit the surface of the Earth. Those which are running into the atmosphere and getting burnt, getting completely burnt in the atmosphere only, they are known as meteors. And therefore, what we see as Toota Tara are meteors. Okay? So to summarize it all, the most gigantic ones are asteroids. They originate from a belt between Mars and Jupiter. Then when they get fragmented, they get pulled by the Earth. When they enter into Earth atmosphere, these meteoroids are now named as meteoroid or meteors. And when, if at all, they manage to hit the surface of the Earth, then they will be known as meteoroid. And why am I telling you all of this? Because the classification among all these celestial bodies have been a clear-cut question of UPSC prelims. So I hope this will help you prepare for it in a better way. So now we have got few questions. Let's try to solve them. First of all, in UPSC prelims 2011, it was asked, what's the difference between asteroid and comet? Okay, so you will try to solve this question and tell me the answer of it, because it has been asked by UPSC. Second practice question related to mother of dragons comet. Consider the following statement. Is it named by NASA? You tell me, is it named by NASA? Then second, it is comprised of ice, dust, rock and diatomic carbon molecule. This is absolutely correct. Then it makes appearances after every 10 years. Is it possible for it to make appearance in 10 years? So kindly answer these two questions in the comment section. Now, a recent study of IIT Madras has made a shocking revelation. The amount of contamination of the perfluoro and the polyfluoroalkyl substances in Indian groundwater is found to be about 20,000 times more than the American safety level standards, which brings us to the question, what is the contamination of the groundwater in India and why is it a big concern? So first of all, the groundwater contamination is not an unusual thing. It happens from both natural sources and artificial sources, but with the growth of industrial revolution and industrialization, and we opting for more synthetic chemicals as compared to the natural ones, this is getting worse. So now, first of all, let's demarcate all the contaminants of water into two classifications. So the contaminants are either natural contaminants or these are man-made contaminants. Natural contaminants are your arsenic, these are uranium, it could be nitrates, it could be iron. Basically, some of the non-metals and most of the heavy metals are one of the main naturally occurring contaminants. They are naturally occurring and basically exploited because of uncovering into the groundwater because of over exploitation, over drilling of the groundwater, because they are situated in the deep beds of the earth's crust, and when you dig the water too deep, then it becomes more often than not it becomes usual that these contaminants will penetrate into the water. Okay, these are the natural ones. What about the man-made ones? Well, there are many, but the point of concern for us is the perfluoroalkyl substances, perfluoro and the polyfluoroalkyl substances. First of all, what is this substance PFAS and why is it creating a menace? This is an excellent synthetic material which has got excellent anti-cohesive properties, which means it can be used in non-stick cookware, it can be used as an excellent stain remover, it can be used in clothing that can be made water repellent, that can be made grease repellent. Why? Because it has got huge resistance, high amount of resistance for oil and grease and water. Therefore, it has got huge applications in not just the cosmetic industry, but also in the manufacturing industry, in the cookware industry, everywhere it is. Now, because it is very heavily used in the industries and also because it is non-cohesive, which means it does not get dissolved by the water. Therefore, it creates contamination in the water. Now, when it creates contamination in the water, it will get penetrated into our ecosystems, the realms of ecosystem, the land, the soil, the air, eventually reaching our consumption patterns, our food cycle. And as a result, because these are very stubborn chemicals, therefore, such stubborn chemicals are also known as forever chemicals because they take a forever time to get degraded. And these forever chemicals, they get stored in our fatty tissues, in the fatty tissues of an organisms, and this leads to what we call as bioaccumulation. Bioaccumulation of such an hazardous substance can lead to many developmental disorders, hormonal imbalances, decrease in fertility, especially in the women. It can also lead to development of carcinogenic symptoms, for example, cancers. So therefore, this is a major issue that needs to be addressed, especially for a country like India, because the underground contamination, the underground water contamination is a very big concern because we are heavily relied upon it. 60% of our irrigation needs are directly met by the underground water only. And we are mostly agriculture economy. So therefore, the food that we are consuming, if at all, if it has get substances like these above the prescribed safety levels, then it will be very harmful for us in order to, as it will be creating a lot of cardiovascular diseases, lot of non-communicable diseases, etc. Okay, so this is a concern, and we have already seen what are the sources of groundwater contamination. It could be many things. It could be urban water runoff, it could be agricultural runoff, it could be some abandoned wells which have started accumulating such heavy minerals, for example arsenic. Then it could be the fracking process by which natural gas and oil is pumped out. It could be because of the falling repair systems. It could be because of chemical contamination, for example PFAS, okay, and Teflon, etc. Now, once we have read about it, is there an international mechanism to take care of such forever chemicals, which are also, by the way, known as the persistent organic pollutants? Now, because they have got huge health hazards, they are already under a regulation created by the Stockholm Convention. So the Stockholm Convention, which came into force in the year 2004. This was requested by United Nations Environment Programme for the first time in the year 1995, and then this convention finally got or enforced. It was adopted in the year 2001, but it got enforced in the year 2004. And as a result, it made the parties liable for managing the products that are creating persistent organic pollutants. So please remember, what is Stockholm Convention? Is India signatory to it? Obviously, India has been a signatory since 2006. What are the defined organic chemicals under this convention? It is first of all those chemicals which persist and remain in the environment. They are not degradable to a larger extent. Second, they have a huge spreadability across the environments, across long distances. Then they have the tendencies to get accumulated in the living organisms. Then they have the potential to cause adverse impact to the human. We've already seen all of these things are matched for PFAS. So is PFAS a chemical under this global chemical convention, the Stockholm Convention? Absolutely yes. Okay, how many countries are party to it? Please remember, about 182 countries are party to it, except for United States, Israel and Malaysia. These three very important economies are not party to Stockholm Convention. Can you also name for me some other waste management conventions? The other one, the Rotterdam Convention is there, Basel Convention is there. Can you write down the names? Can you try to recall the names of there and what is their particular enrollment, date of enforcement, etc. So now we'll move on to the next topic. But before that, can we also try to solve this PYQ of UPSC? It has asked which of the following can be found as pollutants in the drinking water in some parts of India. Please remember, these are the pollutants. What makes something a pollutant? First of all, the concentration is very high. Second, it is insoluble in water. If you're talking about water sources, it's insoluble in water. Then it is bad for human health. It causes bioaccumulation. It causes multiple health hazards. So let's try to figure it out. It seems to me as if all of them are important. All of them can be found as pollutants. But that is not the case. See, arsenic is definitely there, fluoride is definitely there, uranium is definitely there. I'm quite sure about them because these are the very well-known metallic elements, the heavy metals and the non-metals. Fluoride is a non-metal which eventually causes bioaccumulation, which causes huge amount of contamination. But sorbitol is a natural sugar. Sorbitol is a natural sugar. Formaldehyde can be dissolved in water. Formaldehyde can be dissolved in water. So therefore, the correct answer would be fetched. Once I'll eliminate 2 and I will eliminate 4. So where do you find that? The answer is 1, 3 and 5. So even after finishing the entire topic, please give a leeway, a benefit of doubt for the examination that they can surprise you from some questions. But of course, they can be eliminated via logical guesses. Of course, not many of us know about sorbitol and formaldehyde. But at the same time, we are quite sure about arsenic, fluoride and uranium. So back your knowledge. Okay. Now moving on to the next topic. Our next topic is one of the basic fundamental concepts of biotechnology. Biotechnology, which is pretty much in news. You must have already heard about things like genetic, like gene editing, like genome sequencing, some of the advances. But talking about how do you actually decode the genetic makeup of an offspring? That is one of the fundamental basics of biotechnology. And in order to predict what is going to be the inheritance pattern, for that, we study something which is known as Punnett square. To give you a context of it, we have taken an example. We've pulled example where we have taken 2 rabbits. One is a rabbit with black fur coat and second is brown colored coat. Now, when these 2 parents will be crossbred, what is going to be the inheritance pattern? What is going to be the inherited trait of their offspring? This can be predicted by a 4-square diagram. This 4-square diagram is known as Punnett square. Naturally, it is named after the person who has discovered it. So after the Mendelian laws of inheritance, which you must have read in your NCRTs, Then we have got the Punnett square, which was created for the first time by Sir Reginald Punnett, upon whose name this is also named, back in the year 1905, and since then it has become one of the most important benchmarks in order to study the laws of inheritance or to study the probability of inheritance. In order to study the Punnett square, let's first understand some of the fundamental concepts, some of the fundamental topics. These keywords, these topics includes what is allele, what is genotype, and what is phenotype. So first of all, let's say there is an organism. Now this organism might be inherited or might be having a lot of genetic characteristics. It could be about the color of the skin. It could be about how much height is the person going to have, what is the color of the hair, what is going to be their immunity type, and is there any inherited disease that they're going to develop. All of these are some of their genetic traits. Individual genetic traits of an organism are known as alleles. Okay, so let's say we have got so many alleles. Now, what is genotype? Not all the alleles which are inherited by a person gets manifested into their body. Only the dominant ones gets manifested. So when you talk about an individual, the entire address of their genetic makeup is known as their genotype. So they might have inherited either this genotype or this genotype or this genotype, which is nothing but combination of some alleles. Clear on that? Now, upon inheriting a certain kind of genetic makeup, I am supposed to be manifesting some of them into physical characteristics. So because let's say the rabbit has got the black fur as the dominant genotype. As a result of this, the phenotype would be that the rabbit has developed, or the rabbit is a black colored rabbit. Okay, so the physical manifestation of the genotype is known as a phenotype. Okay, so therefore within a species of rabbit you can see so many variations. Why is this happening? Because these are the different phenotypes of the same species because of the difference in their genotype. Okay, now let's understand what is Punnett square and how do we create it with the help of this example. So let's say we have got two parent rabbits. One parent rabbit having brown colored recessive traits having less likelihood of being projected or manifested into the offspring. And the second one, or the black rabbit, has got a dominant trait of giving of or imparting black color coat. Okay, and this is a dominant trait. Okay, and this is a recessive trait. Now, upon their crossbreeding, how many probabilities do I get? That can be judged with the help of creating a box, a 4-square box, where I will be putting separate alleles or the type of genes of one parent, and on the vertical axis I will put the genotype or the alleles of next parent, and then when I will cross it, I will see that this one has a genotype of dominant B and recessive B. This one has a homozygous. This is homozygous because it is having same type of alleles, and as a result this is a homozygous. This is a homozygous allele, but at the same time, is it a dominant allele? No, it is a recessive allele. So this is homozygous recessive. Then when I talk about these two rabbits have got a dominant B and a recessive B. But who will win? The dominant trait will win, and as a result, the product will be, the offspring will be getting the dominant black color. Upon understanding, upon analyzing the genotype, upon analyzing the Punnett square, I can say that there is 50% chances of the offspring, as you can see, 50% chances of the offspring to be having a black colored fur coat, which means to be having the B type heterozygous. Why heterozygous? Because these are not same. So heterozygous dominant trait, and there are 50% chances again that they will be developing a homozygous recessive trait. So the chances of developing brown fur coat or black fur coat is 50-50. Now this is not the same for everybody. It could be in other cases, depending upon the alleles that are coming from the parent, it could be 60-40. It could be 80-20 as well. So this helps us to understand whether a particular disease, whether a particular trait will be inherited or not. And for that, we use, first of all, the Mendelian law, and second one is the Punnett square. So I hope you've understood the concept. Now, we all know about the significance of fuel cells in transitioning towards greener economy, greener transport, etc. But do you also know that there is a more eco-friendly way of creating these fuel cells? And that is by using the sea water as the very fuel for these fuel cells. And this kind of innovation has been made true by the researchers from our very own Kerala University. So let's dive into detail about what is this new type of eco-friendly fuel cell which is created using magnesium, copper and cupric oxide. So first of all, let's understand what is a fuel cell. See now, contrary to the conventional cells which utilizes the process of combustion in which basically you burn the hydrocarbon, and as a result, when a hydrocarbon is burnt, then it gives me an irreversible reaction and also produces greenhouse gases along with water, along with heat. This is a typical combustion engine. Okay, of course, it is detrimental for the environment, and we want to transition towards a better resource, and a better alternative is basically to not utilize the hydrocarbons at all. Rather, utilizing another chemical reaction which is reversible in nature, which is I will make a chemical reaction so that the protons or the hydrogen ions combine with the oxide ions, and they give me something which I know as water, and naturally I will be getting some electrons as well. These electrons can be used in the electronic circuits, in the electrical circuits, and they will help me get electricity. The good thing about these, and how are they more important than these combustion engines, is because the process is reversible. So therefore you would not require the fuel input all the times, and that is why it does not require recharging as compared to the combustion engines. It does not causes depletion of the source, because it can again be recreated. It can again be disintegrated into hydrogen and oxygen, and again you can create water from it and electricity from it. Okay, so therefore these are the fuel cells which are very much in use, much in demand. Why? Because of the efficiency it provides, because of the eco-friendliness that it provides. Now, how a typical fuel cell works? It works on the principle of hydrogen. Inputting hydrogen and oxygen gases which are readily available in the atmosphere, and then combining them into something which creates us the products like heat, energy and your water. All of them are non-polluting in nature, right? Now, instead of using hydrogen, typical hydrogen cell, what we have now thought, can we use magnesium, copper and cupric oxide in the place of the typical hydrogen batteries? So for that, what Kerala University students have done, they have created a battery or a fuel cell which has got 2 points. So basically any fuel cell has got 2 components. This fuel cell has got one negatively charged electrode, and this is known as anode, and one positively charged electrode, this is known as cathode. The ions would definitely move from the negatively charged to the positively charged electrode, and this transition will happen because there is a medium, and this medium is known as catalyst. What happens in a typical hydrogen fuel cell is we generally create the anode and cathode. Their composition is different. They are generally coated by platinum, which is very expensive metal, rare earth metal. And we infuse hydrogen gas towards the anode side. Why? Because this is positive and it will get attracted towards negative, and we will induce the oxygen gas from the cathode side, because this is negative, these ions are negative, and they will get attracted towards positive. This is how a typical hydrogen fuel will work. Now, I will explain you more deeply about it, but let's first understand what are the differences brought by this fuel cell. It is about the composition of the anode and the cathode, nothing else. So here, the anode will basically be made up of magnesium metal. Magnesium element will be used to create the anode, and the cathode will be created using copper. And because this copper, if I dip it in the water, it will start acquiring rust. So this rust of the copper or the cupric oxide will create a coating on it. So here I am getting magnesium as the anode and copper or cupric oxide as the cathode. And this is the working principle. Now how does a fuel cell produces electricity from it? Let's look into the working of the fuel cell. So please pay your attention towards this diagram. As I have already explained you the basics, that from anode or towards the anode, hydrogen gas which is readily available in the atmosphere, so you're not requiring any combustion process here. So hydrogen is getting inputted from anode side and oxygen from the cathode side. Now what happens, once this hydrogen atom gets disintegrated in the anode, a hydrogen will get disintegrated into protium ions or hydrogen ions and electrons. Now, the nature of the membrane which is basically selective membrane, which means it will only allow the passage of one kind of thing and reject passage of another. It will allow the passage of protium ions or hydrogen ions. They can go, but it will block the electrons. So where will these electrons go? So in order to channelize the electrons, we also create an electric circuit over here, which is connecting anode to cathode. And as you know that electrons are negatively charged, they will get attracted towards what? They will get attracted towards the positively charged cathode. And as a result, this flow of electron will give me what? It will give me electric current. It will give me electric current. And this is typical working, and this is how we justify that electricity is getting produced from a fuel cell. So I hope this is clear to you, because fuel cells are extremely important topic. Now please understand something about fuel cell, that first of all they do not require recharging. So they do not require recharging. Second is, the reactions are mostly reversible. They do not cause any emissions as well. So there are no emissions. Of course, they require certain materials. See, the problem with any emerging technology is that they require certain materials which are very resource intensive, capital intensive. They are basically expensive than the previous things. So if it is expensive, if the new technology, the greener one, is more expensive, then why will I resort to it? So the whole intention should be to make it cost affordable, and that is how the magnesium copper cupric oxide fuel cell comes into play. A conventional hydrogen fuel cell, it requires lithium as a metal or lithium in the anode, and also it requires platinum, the coating of platinum in the place of cupric oxide towards cathode. Of course, lithium is a rare earth metal. We do not have lot of lithium reserves in India. So definitely we are import dependent on China, on lithium triangle of Bolivia, Argentina, Chile, right? In order to reduce this import dependence, in order to make it more cost effective, we utilize magnesium which is more readily available, most cost effective, and most importantly, I also want something which is giving me more electrical output. So the efficiency, the energy density of magnesium is higher as compared to lithium. That is also something you need to remember. Next is, how can I replace this platinum? The platinum, which is again a rare earth metal, is very expensive to purchase. So therefore, I can make it cost affordable by utilizing cupric oxide, which can be created by oxidizing copper itself. So I do not require a lot of material over here. So when I transition from hydrogen fuel cell towards the magnesium copper fuel cells, I'm not only ensuring that it is it's giving me more electrical output. It's giving me more electrical output, but I'm also ensuring that this new greener technology is more affordable. So I hope you have understood the entire concept. Now, why are the most important topics that we read nowadays is because all the countries are committed to reducing their greenhouse gas emissions. Which are the main culprits of greenhouse gas Emissions, these are the transport sectors, the industrial sectors, the automobiles, right? So all of that combustion engines can be replaced by the hydrogen fuel cells, especially if it is of this kinds. So it is going to have immense application, right from wastewater treatment to communication technology to transportation to lifting anything to electromagnetic current to creating something which is heavily utilizing the industrial efficiencies. So basically all of them are one of the applications of fuel cell. So if a question comes to you in the prelims exam, which of the following are applications of fuel cell, answer would be all of them, because almost all of the sectors find applications of fuel cell. Now, while we have discussed the benefits, can we also talk about the challenges? Because in order to become analytical, we should know the pros and cons of everything. The first thing with any emerging technology is that it is expensive. In this particular case, it's not that expensive, but it could pose greater safety risks. What are these risks? First of all, the use of magnesium metal. It is highly reactive. S-block element, highly reactive. Whenever it reacts with water or even slight bit of moisture, it becomes combustible. It becomes immensely combustible, creating magnesium dioxide and at the same time producing huge amount of heat. So handling the magnesium metal would be one of the challenges that we need to take care of. So safety concerns is one challenge. Second challenge is its reversibility. So typically a fuel cell is efficient if it can perform reversibility very, very efficiently. But in the case of cupric oxide, in the case of magnesium cells, it can be seen that the reversibility eventually depletes. It eventually depletes the electrodes. So while you can rely on them for constantly producing electricity, they can only perform that for some limited amount of time as compared to the previous lithium hydrogen cells. So I hope this concept is clear to you. Now, India has recently launched a new geospatial satellite. And this is not launched by ISRO, but by one of the private organizations, which is the Tata Advanced Systems Limited. And therefore, the satellite is named as the TSAT-A1 satellite. Now listen, we have entered into an era where heavy privatization of the space sector is going on, and even India is not behind. So India is also promoting privatization. What were the reforms? What are the initiatives that we will learn in the upcoming slide? But let's first understand what is this TSAT satellite and who has launched it. The TSAT satellite is not launched by our PSLV or GSLV because it is not affiliated to ISRO. It was launched by Falcon Rocket. Who has created Falcon Rocket? Falcon rockets have been created by SpaceX, which is a private company of USA headed by Elon Musk. Okay, so this has been lifted by a private sector launch vehicle. Now, as you can see that this must have provided certain remuneration to the US economy. So can't we also utilize our own launching vehicles, workhorses, for example, PSLV, to take contract with other countries so that they create the satellite and we launch it for them? This will also boost the privatization. So the two aspects of privatization is, first of all, creation or production of satellites, and second is creating launching setups or launching mechanisms. And in both the sectors, the government of India has allowed 100% FDI. This is a big news for the Indian economy. Now, talking about this TSAT satellite, it basically is deployed in the low Earth orbit. Where? In the low Earth orbit, which is about 400 kilometers from the surface of the Earth. And this tries to capture the geoimageries. But this is not your typical imaging satellite. It is satellite which is of military grade, which makes the Tata Advanced Systems Limited one of the first, in fact, the first private agency in India to produce a military grade satellite. Can you name some other private launches? So very recently, the Vikram series rockets have been created by one of the space startups of India. This is the Skyroot technology. So they have created Vikram series of rocket. If a question comes, Vikram is created by ISRO, then that would be incorrect. The correct answer is Skyroot technology. Okay, so this was about this DSAT satellite. Now let's analyze what is the prospect, what is the pros and cons of having privatization. So when I talk about opening my space for privatization, I'm calling for more finances, because corporate sector or the private sector calls for having more finances. Why do I need more finances? First is because it will give me capital. So first of all, why do I need more finances? Because the Indian space economy is very underdeveloped. When I'm saying this, it only accounts to nearly $8 billion, which is very less. In fact, it is just 2% of the total global space economy. And this is a concern for us. Why? Because we hold a very rich demographic dividend. In fact, we hold about 20% of the total global workforce that is employed, not just in India, but also in the world. So having 20% of the workforce, total share in the global workforce, we are only contributing 2%. We are only contributing 2% to the total space economy, which makes us take it as a concern that we have to leverage, we have to create more advances, more innovations, more products in the space sector, right? So that can be done once we have money, because we cannot be over dependent on ISRO or the government for that. Therefore, privatization will provide us finances which will help us to fully utilize our potential, exploit our potential. Okay. The second point why we need privatization is so that we create a global footprint. We create a global footprint on space. Our footprint on space is more so important because of the growing space consciousness among various nations. All of them are producing satellites, doing launching vehicles, etc. So which makes space a very big concern, and therefore it has recently been called by some of the scientists as the fourth frontier of warfare. So we also need to very actively engage into that. If you want to engage into that, we definitely need to have more procurements, more innovations, more product development. That can be done by pulling in the private sectors. This will also help us to fuel our space aspirations. So the third point is our aspirations will be fulfilled. What are our aspirations? First of all is to create everything in India, is basically to become self-reliant. Right? So that we would not require Falcon rockets to launch our satellites. We'll be self-sufficient. So it will first of all fulfill our aspiration of making in India. And the second one, it will help us to fulfill our goal of making our own international space station by the year 2035. So I hope these three things are clear to you as to why we require the privatization. And last but not the least, will it also not ease off the stress on the ISRO? ISRO is basically, of course, our premier space agency, but it is mostly responsible for R&D. It is mostly responsible for studies, for research, for developments. It will not be able to take care of the commercial activities to its fullest. So for that, we can take the best players out there, which is the private sector, right? Which is famous for its efficiency, for its productivity, right? So these are some of the pros of having privatization. But of course, it is accompanied by what we know as, it is of course accompanied by some of the challenges as well. One of the first challenge that you will encounter is the regulatory challenge. Regulatory challenge, because this is a new field, this is a new era. This means that government needs to put in a lot of regulations, because private sector is heavily profit oriented. They can become very unruly if they are not regulated well. So you would require a lot of administrative setups. Now, of course, because we need regulation, because we will be creating regulatory models, this might also cause regulatory hurdles for the private sectors, because now they probably have to wait for licenses, they have to wait for a lot of clearances, for example, the environmental clearances, which will demotivate them to pursue the product development and space sector very ruthlessly. And therefore, these hurdles might cause delay and demotivation in the private sector. So basically, we need to find a solution which can give us a balance of both of them. Okay, the next challenge which needs to be taken care of is about the environmental pollution. Now, environmental pollution is moving even to the realms of space, because when you deploy the launching vehicles, they carry heavy emissions, gases which are very polluting, having greenhouse gases, in fact having hydrochlorofluorocarbons as well. So therefore, high amount of emissions is quite a natural expectation if we are deploying a lot of private satellites or private products. So environmental pollution is also something that we need to take care of. Currently, we have got United Nations framework for climate change, Convention for Climate Change. This does not create, we don't have an agreed upon space treaty upon space emissions. Okay, so we need to create such treaty as well. And then we have got one more issue. This is the debris issue or the wastage development. So what happens naturally when a launching vehicle, which is non-reusable, when it puts something in the orbit, then it becomes a debris in itself. Now, because I'm launching a lot of things in the low Earth orbit, which means I'm also having a lot of waste, a lot of debris in the form of parts and some of the segments of the launching vehicle. Now, because this is a naturally moving orbit, it might happen that they start colliding with each other, right? Upon colliding, they will create more further debris. And this will create a cascading effect, and it might happen in future that because of heavy privatization, we might end up covering the entire low Earth orbit with a blanket of debris. And this is known as the Kessler syndrome. What is it known as? It is known as the Kessler syndrome. So we need to take care of that as well. So therefore, we need to have certain binding treaties among the nations so that our emission concerns, debris concern, regulatory concerns can be taken care of and they can be standardized. Okay. Now, I've already told you we'll be talking about some of the measures. The first measure is to allow FDI. So initially it was 74%, and in fact it is 74% in some of the segments like operations. But when it comes to development, when it comes to launches, Indian government has enhanced this FDI up to 100%. So 100% FDI is now allowed under the privatization in the space. The second we took effort was in 2019 when we created a dedicated public sector unit or public sector undertaking. The name of this PSU is New Space India Limited, which is under the Department of Space. And this is responsible for bringing together the industrial consortium and encouraging them to produce launching vehicles. I've told you the two aspects of privatization. One is to produce launching vehicle. So for that, NSIL, New Space India Limited, has been created. This is a central PSU. Okay. The third one, a very important one, was a dedicated autonomous single window clearance that was created within the Department of Space. This is IN-SPACE. So IN-SPACE has also been created, which is going to work as an interface between two bodies. One is ISRO. So ISRO will be providing guidance and products will be created by the private agencies. So it is going to become an interface. It is going to tell the private agencies what is the demand of the ISRO, and it will tell or suffice the ISRO's supply, right? So it is going to act as an interface. So when we are going to talk about the measures, these three are the main measures taken by the Indian government to promote privatization in the space sector. So I hope this is clear. Fine. Now, do you know what is the time on the moon right now? Well, it is the same as that of Earth. But is that fair? Because we know that these are two different geospatial bodies and they have different gravitational pull. So according to the Einstein theory of relativity, it's not quite possible, and still we are doing it. So that is why a concern has been brought forward by multiple governments, and therefore agencies like NASA, European Space Agencies have recently been called out to create a dedicated, coordinated universal time for Moon, specifically for Moon, which is not same as that of Earth. What is the need for it, do you wonder? The need is the growing privatization, because we are making a lot of expeditions, lot of private players, lot of other governmental space agencies are now coming forth and trying to venture out and Moon. So in order to coordinate all of these activities, by so many players, we have to create a dedicated time which is very precise in nature. Now, why is the current time not precise for moon? Let's first understand the current timekeeping. The current timekeeping that Earth follows is known as the Coordinated Universal Time. The Coordinated Universal Time, which is basically created by International Board of Weights and Measures. This body, which is headquartered in Paris, gave a standard of time. You know how our time looks like? We have got 365 days worth of 1 year, we have got 30 days for 1 month, and we have got 60 minutes in 1 hour, and we have got 60 seconds for 1 minute, and the SI unit, the smallest unit of time that we have right now, is basically 1 second. But have you wondered who gave this? So this has been given by the International Bureau for Weights and Measures, which is situated, an international body for standard weights and measures situated at Paris. And this Coordinated Universal Time was given to us in the year 1960. Now, how do you measure 1 second? Who has told us that what measures 1 second? This is a very interesting fact. 1 second is the amount of times a cesium atom vibrates. So a cesium atom, which is highly stable in nature, when it vibrates for 9.1 into 10 raised to power 9 times, that is when we count it as 1 second. So there is basically a very stable and a very scientific backing to what you consider as 1 second. And of course, sometimes we get leap years, sometimes our Earth rotation changes. So definitely we need to modify it as well, and this modification is done duly. But is it fair that we calculate this universal coordinated time which we follow on Earth for Moon? For that, let's analyze both of them together. So just have a look into these two gravitational bodies. Earth is a planet and its satellite is Moon. The only satellite of Earth is Moon. We know this. Naturally, this is lesser in weight as compared to Earth. Now, according to Einstein's theory of relativity, the heavier the body is, more gravitational pull it will be having, which means it will distort the time more. Which means that as you reach towards the Earth, as compared to Moon, the time will slow down. And naturally, it also means then the time on Moon is little quicker as compared to that of Earth. Why? Because of the lower gravitational pull, because of the lower weight. So therefore, time moves faster here. How much do you ask? So it runs at least 58.4 microseconds faster every day. And do you see the result of it? The result is our 1 month comprises of 30 days. But when it comes to Moon, it completes 1 day, which is equivalent to our 1 month basically. So it completes its 1 day in a faster speed. So it completes it in only 29.5 days. So basically it is more faster. So when I'm trying to impose my coordinated time, my universally declared time on the Moon, it will not give me precise results, and precise results are the need of that, especially when large amount of lunar space competition is going on. Let's imagine we have got two agencies, okay, agency number 1, agency number 2, and they both are competing with each other, both for very efficient and precise soft landing, right? They are competing among other world economy and they want to claim their prominence here. So the first one will say that I have finished the soft landing in 8.4 seconds. The second one will say that I have finished it in, let's say, 8.42 seconds. Now, do you understand? We are about to declare a winner and the space competition is going on. So the preciseness of the time is very much required. And for that, we need to specifically create a universal coordinated time for Moon with respect to Moon. How do you create that? So how do you measure current Earth's time? By deploying atomic clocks. Atomic clocks behave differently in different latitudes. In equator, it moves more faster. In other parts of the earth, it becomes slower. Okay, so basically the atomic clock varies in speed with respect to where it is positioned in the earth. So just calculating time of one atomic clock is not enough. We require and we deploy about 400 atomic clocks in different parts of the earth, and then we take average of it. What is this atomic clock comprising of? I have already told you in the previous one, atomic clocks are primarily comprising of cesium or rubidium. Okay, rubidium is more concise, more precise, but most often we use cesium in the atomic clock. So what do we use? We use cesium. Right? When we take average of these 400 atomic clocks, that's when we are able to get that 9.1 into 10 raised to power 9. These are the amount of vibrations required to calculate 1 second. Of course, this atomic clock, which is varying in its speed in the earth itself, depending on the latitude, of course, it will vary in speed when it enters into moon. So what is the need of that? We need to deploy certain atomic clocks. In fact, it is said that 3 atomic clocks will be deployed in different parts of the moon. Their average will be taken off, and then it will help us to decide what exactly is 1 second on moon, which is naturally faster as compared to that of earth. Now, naturally, you've predicted it right that this is going to be a very capital intensive project. So what is the need of the hour? Need of the hour is international and global consensus and collaboration for the development of a newly made coordinated time for the moon for more precise results. This is all about my part of the science and technology discussion. I hope you've liked it. I hope it was worth your time, and it also maintained with your timekeeping. So thank you so much and have a nice day.